AGC is going to mirror what you see on the screen there, because the computer's driving it, so it's plugged into the connectors. We could start it from here and run it just for convenience, because his hands are on there. He's going to use the keyboard. So they're in the lunar module, Aldrin and Armstrong. They're in this orbit around the moon. They separated from the command module and they descended, so they're in this loop that comes down to 50,000 feet at its lowest. And when they get there, they're going to figure out how to fire the engine to slow down and land on the moon. And the computer's involved in most of this, and you'll get an idea as he runs. So here's the simulator. So he's going to start the program 63, which is the code that starts the powered descent. So he does that, and now the computer is busy calculating what kind of burn it needs. So it's going to calculate for a few seconds and then show us how long the engine has to burn, when it has to start, and how close we'll be to the landing spot. So he's turning on a landing radar circuit breaker now as part of the checklist. So we'll just wait. There it comes up. So now it's telling us 9 minutes.
Yeah. This happened last week, so I'm going to restart this.
He's going to restart. There's a little flaw with running the simulation.
Show the 1201 and 1203 program lines?
Do we have a 1202?
Yeah, I think we'll get one or two.
We should get a couple of them. We have slightly less load than that, but we'll see what happens. What's amazing when you see it in real life is it's so fast you don't even notice it if you're not looking for it. The light goes on, the computer restarted in a fraction of a second, continues doing what it was doing. So occasionally it goes blank, but the spacecraft's still in control, it's still on the accurate landing path, so just amazing reliability. If only Windows did that, right?
It was set up in the programming, right? So it would go on to the more important.
Right, and they would also checkpoint where they were in every important job. So if they restarted, they could continue right in the middle. Or we were at this angle burning this amount. So
Priority was
We got the right numbers. We got the right numbers now.
okay, good. So 9 minutes and 50 seconds is how long it's going to burn. And we can start in just less than 3 minutes. And then 0.4, so we're 0.4 miles off feet. 0.4 miles sideways from the actual spot. So we're not exactly aligned. The elliptical orbit isn't exactly, but 0.4 miles is close enough to adjust it manually.
So I'm going to press enter to skip this display.
So when it flashes things, that's giving him like feedback saying, do this, perform this from the checkpoint, from the checklist. So he's going through steps here. So he's turning some switches on to make the flight instruments be powered from the AGC. So the needles and everything else will start reflecting what the Apollo guidance computer sees is going on.
So I'm going to press proceed now. This is an auto maneuver screen.
Okay.
So it's going to position the LEM to be pointing in the right
So
direction.
it's doing an auto maneuver right now. It's moving the LEM around a little bit to be in the right position. Looks like you're pretty close already.
And note that the triangular windows and the controls here are exactly the same as the windows and the controls over there. So this gives you a view of what the astronauts would actually be looking at. And we only have these small triangular windows to see the moon's surface.
And the regular, all the landings except Apollo 11, the design was they were lying on their back with their feet pointed where they were going, looking up at the sky. Weren't seeing the moon at all for most of the landing. But Armstrong wanted to be turned around like this, so they're lying with their face pointing straight down, so he could watch his maps and say, well, we're supposed to pass this crater at 2 minutes something seconds. And so he knew right away they were going to land a little long because it wasn't lining up right.
So the Apollo 11 code has a bug in it. It doesn't handle the landing radar perfectly. So I need to do a quick workaround here to set up the radar correctly.
Again, you can see the disk is sort of. So anytime it's flashing, it says it's doing something that's sort of blocking other activity. So you'd have a key release flashing, you have to release it. So if you go back to displaying the main information.
Did they have to do the same workaround
It's
in
like
real?
a pop-up. It's
Did
like
they
a
have to do
window
the same
pop-up.
workaround in the real landing, or did they have to do the same workaround in the real landing, or is this just something you
So it's about-
discovered?
The workaround, no. It was because of the way I loaded
Oh,
So
okay.
we loaded the scenario and started in the middle of a flight rather than having been there. So it was just one flaw and restart.
Oh, okay.
So the screen just went blank, and that was my cue to arm the descent engine.
Okay, so he's armed the descent engine now. See that alt light, this light here, this is warning us that the radar does not yet have a lock on the ground to have accurate altitude. So it's going to go out sometime during this once it gets accurate information.
Please move that wire from the front of this camera.
Sorry, move with
That's wire that's right
Oh,
into the
sorry.
Thank you.
So our descent.
So when are you ready to do that? When are you ready? Testing that first.
In 7 minutes.
Okay.
Okay, so our engine is on at 10% right now.
Okay, the engine just throttled all the way up. So you see those lines went up. So it's burning. So we've got a display here that's showing us our velocity, and that's going down. And it's telling us our descent rate in the second line, and then at the bottom it's showing us kind of a cumulative change. So they're able to monitor that screen and showing, okay, we're at
Just the last line is the altitude right now. So we're at just under 47,000 feet.
47,000 feet and continuing to descend.
So the last line is the accurate.
So this is altitude, this is descent rate, and that is speed.
Yeah. So this is the Disky didn't have decimal points on the display, so you just kind of have to know. So the first line is 5,000 some feet per second. We're descending at 13.2 feet per second, and then this is just 46,600 feet.
Every time they did a different screen, they'd have to remember where a decimal point went.
Yeah, so at this point we're just watching the surface, watching the numbers on the Disky here to make sure we stay on roughly the right trajectory.
They had checklists they had to remember of all of the verbs and nouns to type in. So a lot of training for the astronauts because this was so central to controlling the spacecraft, figuring out where it was, how to burn the engines. It was the actual autopilot. It was the first fly-by-wire system. So they had no direct control over the thrusters. They were just asking the AGC to do things, and it would decide to fire the thrusters based on that.
I thought I read somewhere that they used an AGC as a development mule for fly-by-wire.
Right. Neil Armstrong was
Yeah.
at the Edwards
Yep.
Test Center, and he said, I know a perfect computer to do fly-by-wire experiments because it worked for us in Apollo, so they put one in an F-8.
And I have a friend that knows that computer.
Yeah. But,
Yes,
so another one of these exists.
He'll show you this. So he would call up a screen, they would show that information.
That's pretty amazing.
But, you know,
So
I
we're
don't know that
as
any
Will said,
other
we're flying heads down
computer
right now,
out there,
looking at the lunar surface.
if people are going to go to
We're gonna do a big yaw.
So he's going to have to roll. So remember, we're looking down, but that's
As
not
far
the
as
way we
we've
want to be.
gone.
They want to
Yeah.
roll around so
Because
their feet
with
are
a
pointing
potted
toward the
computer, they're
landing
not gonna
spot
be able
and
to
we're
do
looking
this
up in the
probably.
sky. So he's going to rotate this, and you'll see out of the
You'd have to be
window.
you'd have to be
see
luckier
that
than you guys
eight
were even.
the spacecraft rotate around.
Yeah, that was done at ignition plus 3 minutes and 30 seconds.
Okay, so
I'm
we're
just
at
watching this
3:22. He's waiting till the clock gets to 3:30. That's when Armstrong would have said, okay, now I'm going to go into the correct orientation for the rest of the lesson. Okay, so see the ball starting to spin around?
So the joystick is giving inputs to the AGC, and the AGC is figuring out how to fire the thrusters to rotate us around to get to where I want.
End up with that.
Oh, I'm not there and I don't feel so good right now. This is like the Wonder Wheel.
Oh, this is great.
Are you getting this on video?
Yeah.
No, I was going to physically pitch it up. I wasn't going to rotate it.
Aerobatics above the moon.
Light should be flashing on. I got a little code error in it, so the thrusters will light up as the AGC fires it, and then this
Hey, I see
engine
stars.
has been glowing different brightnesses.
So
Who did the graphics?
this has been like a 10-year development project. You can download this offline.
You did.
No, I didn't have anything to do with this. I only hooked it up to the AGC. That was all I did.
Yeah, he corrected their simulation of the AGC.
Well, we're at 28,000 feet.
So this is something called Orbiter that was created as kind of an open source project to simulate the space shuttle originally. Then some other people came up with an add-on, NASSP, which would do Apollo.
So I'm now displaying Verb 16 and 68. This is displaying our landing radar parameters.
Right.
So the last line here is telling me that we're getting measurements from the landing radar. The altitude light has gone off, but we are about 4 kilometers lower than the AGC thinks we are. Or sorry, 4,000 feet. Yeah. So I'm going to do Verb 57 enter to start incorporating radar measurements.
Yeah, the reason was that the estimate they had for the height of the landing spot was wrong. So they had a bad estimate from having done it on previous missions and taken pictures. And so when the radar actually started bouncing off the ground, it said, no, you're off by this amount. And so by putting this in, it's averaging the radar data and gradually adjusting the computer's view until it knows the actual altitude. That's delta H, yeah. Difference in height between what the gyros thought, the computer thought, and what was actually being measured. So that goes down to near zero.
Yep. So we're down to.
So if you listen to the soundtrack of this, at one point you'll talk about delta H is going down nicely, it's low. So you can hear the mission control talking about that.
And then the second line here is the time remaining in braking phase.
Right, so we have 3 minutes left in the braking phase. We're continuing to slow down.
But it switches into the approach phase with 1 minute to go, so I've got 2 minutes left.
So in a couple of minutes, so it's been in this program 63, which is it descends to a certain point, and then when it gets to the right point in time, it's going to go to the next phase where it pitches up so they can see the ground, and then they're going to start the actual approach. That's the first point where the astronauts are going to see.
So we have in 5 seconds here, we'll have throttle down. That's a big effect.
Okay, so watch on the thrusters up there. See that those lines just went down. So it throttled down to 57%, and it's gradually lowering the engine thrust as they continue to slow down.
And now at 7 minutes, I'm going to evaluate manual control.
Okay, so now he's going to make sure that the spacecraft will rotate and so on correctly. So he's going to use the joystick, and you'll watch the ball, and you'll see it moving slightly as he verifies, pitch forward and back, roll and yaw works. So once you're okay with that, he clicks the switch to put it back into full auto mode. The computer's flying it. Because that's important when they get close to the ground, they need to be able to control it.
Okay, so 1668, so we got 50 seconds left until we go into 64.
So what you'll see at that point in about 40 seconds is this will go to 64, and you'll start seeing us rotate the view of the moon come up in the window, and that will rotate a bit. So this is pretty automated. In fact, the programs were written so it could have landed itself on the moon. There's an automated phase, but every mission the astronauts took control and did the last bit manually.
By 13, they just removed the thing.
Oh, they did? Okay.
Or the automatic modes, right?
Did you guys get a tech manual or anything?
So all of the documents, are in the National Archives and other places. So we've been extracting all of them. So there's how many thousand pages?
I have no idea. We have terabytes of documentation. Yeah. Okay, so we're in G64.
Okay, we're in program 64 now. So we're sort of pitching forward. You should be able to see. See? So now this is the view. Those numbers vertically are a scale that would predict where the thing is going to land. And so when he puts in this display here,
yeah, so I hit proceed to allow redesignations, and in this mode, I can move my joystick just a little bit to change where the AGC is.
Yeah, so if he moves it forward or back, it's going to adjust to land further or back, and he moves it side to side. The side you want to swing. So he's kind of looking to decide where on this he wants to go.
So this number here, the
and
50.
It shows a 50, or now 49. So that's saying if you look at 49 on this, that's where you're going to land.
But that number is up to 2 seconds delayed, so you kind of have to account for that.
So he makes little changes and waits for it to adjust. Now 44. He's going to the side a little bit. So now if you look at about 42, right about there, 41, so that's about where it's going to bring us to for the landing. 36. 37. Okay, you're really designated. So just above that crater, right? 32. So just beyond that crater that's at about 31 and a half is where he's targeted the land. So it's continuing to take us down to lower speed.
So I'm pretty happy with where it's taking us right here. So I'm just gonna sit here and
So bottom is altitude where R1 is.
Here you can see the shadow.
Shadow?
So that gives you an idea of how close you are.
So they start seeing the shadow of the lens. So everything was planned so that the sun was at a low angle and behind them for the landing to give them maximum visibility.
So as Aldrin is calling out the readouts on the disk,
Right.
Armstrong is looking at the graticule.
Right, exactly.
I'm
So,
going into P66 here.
okay, so now this jump to P66, that says, okay, you've taken manual control. So now the computer is only controlling the vertical descent rate. And he's got these buttons that he hits to have it descend faster or slower. And then he's using the joystick to kind of move forward and back. So he's deciding when he has boulders, time to move forward. He's got about 8%
So I'm doing
fuel
about
up.
going forward about 8 feet per second.
Right. So you'd hear Aldrin saying things like forward 8, down 2. He was reading the display.
Kicking up some
to make
dust.
sure Armstrong knew.
Oh yeah.
Watch the blue light up there.
So that blue light is lunar contact. As soon as the dust is coming up, and as soon as that lights up, it means the prong has touched the ground, and it's time to shut off the engine.
So I'm going down about 1 per second.
Nice and slow, right? He's really stretching it out. Contact light, so he turns off the engine. So he's got a couple of steps to do to ready it. So he's got to turn off the thruster so it doesn't try to tip the thing over around the ground.
13 speed override.
That's right. This is the point.
So now we make the call for stay or no stay. Are we gonna abort?
So should we abort? Why don't we try it? Let's hit abort stage and get out of here.
Okay, so we're not.
Watch out the window when it hits abort stage. There we go. So that was the whole system. Up we go. And so now this abort system is going to take us right back to orbit. The program's still in the AGC. That's all the program.
Yeah, P71 is the abort
Yeah,
program.
yeah. So when you hit the button, it's switched.
So this will just take us all the way back to orbit. They designed it to be as safe as possible. You have the one button,
It
you
goes
press
in
that
orbit.
button, and it's
I
upright
was
speed.
thinking exactly the same thing.
So the Grumman hardware fired the separation, pyrotechnics, lit the engine.
Frank, in about 5
watched the
minutes, we're going to have to run out to our
Okay.
next show.
Well,
Yeah, so it was all done by this guy. He did pretty much everything except the attitude control. Yeah, and it's taking us back to orbit now.
I guess Mike should be proud of himself because he's doing what it took 2 men to do in real life.
Well, we're reading off some things to him. So he's done so much practicing with this now. He's probably the most experienced person right now in doing lunar landings with software. Other than the real astronauts who did it. Because everyone else with the simulator hasn't done that many landings. So it's pretty good. When we tried it, we were crashing and everything else.
So he's prime choice for the Artemis mission.
He is.
And he really kicks ass at Kerbal Space Program.
Which commanders still alive? Dave Scott and Phyllis.
Commanders, let's see which commanders.
They're the ones flying.
Conrad's not alive.
James.
Pete Conrad is
James?
dead, John Young, Alan Shepard,
What a
Jim
great
Cernan.
What a great for your program.
Yeah, I think the commanders are, but lunar module pilots and
Since the commander was flying, it would be nice to get Dave Scott to actually do a proper demonstration. Yeah. I'm sure he would say,
we
Well,
love
it's
that.
completely hands-off. It just flies itself.
Yeah, wow. Well, I guess that's what it's supposed to do.
The 1201 and the 1202.
Yeah, apparently I set up my config file wrong and that didn't
I
happen.
guess it's
Just
just
do that.
go straight up until you actually have to try to dock.
Quickly or long way